And welcome back, and it is the 9th of March, further maths, 5 a day, and let's just go with the first question. Right, so we have two lines. The line L1 has equation y equals 3x minus 12. Find the coordinates of P. What? Oh, okay. Sorry, I was a bit slow there. I like this question. This is a clever question. I was going to say, can't you just read the coordinates? But of course you don't have any numbers, do you? And that's the whole point, because I need to use line 1 in order to get the numbers on the scale, which will then allow me to use the numbers to find P. So I'm a bit slow with that one. Anyway, point is, if I consider, so let's zoom out again, if I consider the equation line 1 and I let y equal to 0, well, that means that 0 equals 3x minus 12, which means that one of my values on the line must be, well, x is equal to 4. In other words, my crossing point of line 1 is 4, which means that's 4, that's 2, 6, 8, and 10. So I already got, for P, the x value, which is going to be 10. Similarly, if I let x equal 0, well, this one's a little bit easier. So x equals 0 gives me, x equals 0, which is minus 12, not minus 12, 0 minus 12. And so therefore this is minus 12. There is 1, 2, 3, 4 squares. So 12 divided by 4 is 3, so it goes up in 3. So minus 9, minus 6, minus 3. But of course I don't really care about that. What I do care about is this is 3 and this is 6. So it took me a while to get there, but point P is the point 10, 6. What a clever little question. Next question. Find the equation of line 2. Now, in order to find the equation of a line, I need two things. I need the M and I need the C. Well, the C is fairly easy on the graph because I'll just carry on going. So 9, 12, 15, 18. So my C term is 18. And the M, well, first of all, just to note something that is probably obvious, but it's worth noting anyway, is I'm going to highlight it in a colour. I am clearly going down. And if I'm going down, that means my gradient is negative. And I'm going down 18 while going across 6. So therefore my gradient is minus 18 over 6, which is otherwise known as minus 3. So therefore my line is going to be y equals minus 3x plus 18. That was, having not worked out what was happening originally, that was actually a really clever question. I like that question. Next question. OABC is transformed by the matrix 0, 1, 1, 0. Now, before I even look at it, because I know it's going to be unit square, but before I even look across to the right, I can think that my normal matrix, so the identity matrix, is 1, 0, 0, 1. And I can see I've switched my x to my y with my x. So looking ahead, I don't often do this, but looking ahead, I can see, I knew it was coming. Describe the transformation fully. It is a reflection in the line y equals x. And that's important to know, because actually if I can get that, then I don't have to mess around trying to work out what the new coordinates are. I just know what to do. So I'm going to do it in different colours, so it's really clear, because the problem is that the points are on top of each other. So on the face of it, it is still the same box in the same place, but now my C has gone to my A has gone to my C, and my B stays where it is. So if I was doing this in an exam, I would write, I'm going to draw it over here just so I can be clear what I'm doing, because it's very difficult drawing on top of something. I'll be writing C prime here for the reflection. B and B prime are the same. This is A prime, and O stays where it is as well. So not too bad as a question. Nice question, just pretty hard to show on the diagram. Next and final question of today. Find the coordinates of the stationary point. So it's a stationary point question. And now if you watched any of my videos by now, this should be becoming pretty familiar. So stationary points mean gradient, more specifically gradients equal to 0. So if nothing else, I'm going to differentiate. That will give me some marks in the exam. Bring down the 3 times the third is 1. That's going to be x squared. Bring down the 2, which is going to give me 10x. And 21x just becomes 21. Now this feels an awful lot like something I can factorise. Remember, I want this to equal 0 for the turning point. So that's going to be x plus 7 plus x plus 3 equals 0. Which implies, now what am I doing? Find the coordinates of the stationary point. So I need the y values as well. So therefore x equals minus 3, or it's the case that x equals minus 7. So basically I'm going to have to put these back into the coordinate equation over here. So let's do that. So x is minus 3, so x is minus 3. That gives me a third. Minus 3 cubed is minus 27, plus 5 times minus 3 squared is 9, minus 21 times 3, I'll just move the minus to the outside, plus 3, and all of that's going to give me, well, I'm not even going to risk it, I'm doing it in my calculator, so it's minus 9, plus 45, minus 63, plus 3 is going to give me minus 24. So the first one is to minus 24, read my calculator correctly, minus 3 minus 24. Same thing with 7, so this could be a bit messier because it's not going to cancel with 3s nicely. So x is minus 7, which is going to be a third. Well, minus 7 cubed is minus 343. Not looking good already, is it? Plus 5 times 49, because the minus goes away, minus 21 times 7, which is 147, plus 3. All that in my calculator, so I've got minus 343 over 3 plus 5 times 49 minus 147 plus 3, which gives me a final answer of minus 40 over 3. 40 over 3, which means the second turning point is going to be minus 7 minus 40 over 3. Is that what it wants? It doesn't want to know what they are. It doesn't want to know the nature of the turning points. So therefore, 2 coordinates. Those are both my answers. And that is today done. Wow, I quite like that first question because that first question threw me. Indeed, clearly today, we'll change pen halfway through. Clearly today has been a interesting day, slightly different set of questions. Do let me know how you did. I thought they were quite good. The last one was a pretty standard question, but the rest of them were a little bit different. As ever, like, subscribe, and I'll see you for the next one. Thanks all.